I'm Reema Jain, and today I would be giving a presentation on my paper Review of EMG Signal Classification Approaches based on various feature domain. This paper is presented at second ICSTR Istanbul International Conference on Science and Technology Research. This is under the supervision of Dr. Vijay Kekar. So let's begin. First, we'll see what we are going to cover in this presentation. I'll be giving an introduction and then what is the importance of EMG in today's life. After this, the methodology of my survey, then the review that I have found after doing the survey, and then the results and outcome, and finally the conclusion. So let's begin with the introduction. What is an EMG? EMG are nothing but these are actually the signals recorded for any muscular activity. When there is any contraction or expansion of the muscle and we want to record that movement, then this can be done with the help of EMG machines, and the signals, the recorded signals are called the EMG signals. So these signals can be used by the doctors for further diagnosis of any muscular or nerve disorder in that region. But the main problem or the most important hindrance that is found in this complete process is the signals are complex and it might consist of noise, and these noise are mixed with actual data and at the end may form a challenge for the young researchers and also the medical practitioners, as the results may deviate if the noise is present in the data. Hence, this form as a matter of research for creating a good system which will be free of noises. So, what EMG? Now here I have included a pie chart which shows the EMG device market share. This can depict how much EMG is being widely used in almost all parts of the world. If we see here, Europe holds the maximum percentage of 31%, followed by North America using EMG devices at 29%, Asia Pacific at 19%, Latin America at 12%, and Middle East and Africa at 9%. And if we compare the EMG device with other devices like the EEG, ERG, and fetal scalp or the other devices from the last 10 years, it can be easily seen that although EEG shares a maximum market share, it is having the maximum percentage of the market share, it is being closely followed by EMG, which is at the second position. In the past years, although it's more or less the same percentage, however, if we see the prediction that is from 2020 onwards, there is an increase in the use of these devices. Hence, here lies the importance of this EMG area, because this will be always a field of study as it's going to be popular in the upcoming years. So this paper holds its importance because of the reason of the use of more EMG devices, and hence we need to prepare a system which is 100% which gives a good results and good outcome. Before beginning into the actual system, first let's see how a system works. At first we get the data and then features are extracted. The extracted features are optimized, and then the features are trained using some classifiers, and then that is stored. After this complete steps is called the training steps. After this, it is followed by the testing part, wherein the data is loaded, the features are extracted, and finally with the system we identify and classify the data, and on the basis of the output the accuracy of the system is evaluated. Like if we get a good output, then the system is better. So if we can say in jest, then the feature extraction and optimization and the classification, these three steps form the basis of the good working of the system. Hence, if the features are extracted accurately, and optimized and classified, then system is good to go. So let's first see how the features are extracted. The feature method, first is the time domain and second is the frequency domain. Time domain means when the signals are measured in the interval of time. In the that means like the amplitude are measured in time, like that in a period of time, then that is called the time domain. And when the amplitude are measured in terms of frequency, then it is called a frequency domain. Most of the time the features are extracted using time domain, and at times we can see there is a combination of time and frequency domain both. So this way we can extract the features. So let's see what methodology I have. Firstly, I have collected the data for the last 10 years, that is from 2010 onwards till 2020. Then I've focused on what is the method of this EMG classification and feature extraction. If the data is related to the EMG, then that is being taken forward, and on the basis of those data, survey is done and the results, like what are the feature extraction techniques, classifier you used, and optimization method, and the performance, everything is finally tabulated, and then results can be results, I'll be sharing this results at the end of the presentation. So this is finally the outcome of my survey. All right, so let's see review of my survey. As we have seen, features are extracted. Now the next step is optimization of the feature. So which actually means like whenever features are extracted from the signal, it's not like we use all the features that are being extracted. Instead, we have to select the relevant features for the further classification and training of the system, because if we give more features, and the system might get confused, and if we give less features, the system might not give the correct result. Hence, from the survey, it is being found that in last years, uh, the techniques which are most commonly used are: first is cosine similarity, second is principal component analysis, third is wavelength transformation, and fourth is genetic algorithm based reduction. These were mostly used for the feature reduction methods. Now, in this regard, uh, this a survey is being done here on different techniques to see which is the better technique. So here cosine similarity, PCA, GA, and a new technique of the combination of cosine and genetic algorithm is being conducted to see the efficiency of different techniques. So this all the techniques were applied on a same set of data to see the outcome and the accuracy. When this was done, something like this. For the like the data consist of two classes. One is pain data, another one is non-pain data, and the accuracy of different techniques are displayed in this table. When if we see carefully, then we can find that overall GA and cosine gave the promising results. Although the GA results were also good, like in case of non-kin, it is slightly better than this combination. Yet, if we see overall, then GA and cosine could be a method which can be used further for research purpose. Of results and outcomes of my survey, these are all the good papers that I've included from good journals, and like the Elsewhere and the Scopus. So IEEE, all the good papers are included in my this table from for last 10 years. And if we see, the features extraction method is mostly time domain, and at times it is time and frequency domain. Classified are mostly neural networks. Apart from that, SVM is also widely used, and the accuracy of the last decade, if we see, is actually improving and showing increasing trend only. So this table can be used by different researchers for their further study in this area. The sampling technique, if I talk about, there are two methods in which we can get the EMG data, EMG signals. First is called the surface EMG, second is called the intramuscular this intramuscular method. In surface EMG, obviously it is more popular and painless application, so it is mostly preferred by us, the subjects. However, intramuscular one, although the computational cost is higher, but this gives more better results than surface EMG. Classification approaches, if we see of the last 10 years, then LDA and ANFIS were popular in beginning years, like from 2011 to 14 onwards. We can see these were popular. After this SVM started gaining popularity, and then neural networks are actually in most widely used in these area. Most widely focused method is neural network in recent years. So, conclusion, what of this paper, I would like to say this paper consists of all the EMG signal classification, feature extraction method and optimization method, and the classification techniques used in the last 10 years, which can be used as a baseline for the future studies by different young researchers. So definitely this is going to be a good resource for creating a human computer interface for future research. So I would end my presentation at this